students, welcome back to Homeostasis. So for today's part of the video, we'll be looking at the structure of the mammalian skin and how the structure is involved in homeostasis of temperature itself. So you will have to identify the different parts of the skin itself, and you're expected to. Okay, but of course certain things like cornified layer, granular layer is not really in the syllabus itself. So key things that you will have to take note, okay, will be things like your capillaries, which carries the blood towards the skin itself, especially on a hot day, or it carries blood away from the skin during extremely cold periods. So the sweat gland, as the name suggests, it will carry the sweat out to the environment, and that's when upon evaporation the sweat will remove a large amount of heat from the body system. Okay, so how is it that it senses temperature? It's by this particular receptor, which is called thermoreceptor. Temperature, so thermoreceptor. Okay, and we have got touch receptor here, which allows you to sense touch at the skin region. Nothing to do with temperature, it's just an additional component of the skin itself. Okay, so at the bottom part of the layer, when we go down, we have got the sebaceous gland. So the sebaceous gland secretes oil products which will help to moisturize the skin. So some dermatologists, they will mention that when there is excessive secretion of the sebaceous gland, you have got clotting of the pores, and that's why some people are prone to things like acne, or you have got infection of the skin. Okay. We also have arterioles. So arterioles and capillaries are both involved in the amount of blood that is being brought to the skin surface, be it during a cold day or during a hot day. Okay, so we have got adipose tissues. Adipose is another term for fats. These circular components are your fatty deposits. So the fatty deposits help to act as a layer of insulation for the body, in which it is able to trap heat and to maintain the inner body temperature when you are in extremely cold climates. Okay. At the same time, adipose tissues, they also contain fat-soluble vitamins, which we learned under biomolecules. Okay, so these are the different parts that I mentioned about in the table. Okay, so just take note that when we look at kidneys, it is a form of excretion because it removes the urea away from the body. So in the same way, the sweat itself is removed through the skin, and therefore it is considered an excretory organ. Okay, so skin is one of the most major organs on the body itself, which is why when you have got burnt patients with 30-40% percentages of burnt, their chances of survival is reduced because a major organ is being burnt. Okay, so sweat not only removes water, it also removes things like electrolytes such as your salt, also have small quantities of urea component. Okay, so let's move downwards to look at the component, how it helps in terms of your heat production and heat loss. So as we know, our body core temperature is maintained around 37 degrees Celsius. If we have a fever, they will go up 35, 37.5 and so on. So anything below 34 degrees Celsius, the person have hypothermia, in which the person gets extremely cold and the movement slow down, and eventually death might take place if left untreated. When temperatures get too high, you are rushed to the hospital because the components like your enzymes may possibly stop working, and you can suffer from brain damage. Okay. So how is it that despite the daily metabolism, the daily heat that is being faced by people in certain countries, the human body is still able to survive? Is due to the heat that is being lost to the environment. Okay. So heat can come from different forms. It can come from, there is internal heat gain and there is external heat gain. So internal heat gain will be things like your muscular activity or chemical reactions from metabolism. External heat gain can be things like the food, drinks, also direct sunlight that you face if you are living in a very hot climate like Singapore. So chemical reactions in the liver, just take note. So over here, we now learn another function of the liver is to maintain heat concentration in the body itself. okay, or is to generate heat. Okay, so under nutrition, for nutrition in humans, we have looked at the liver rather closely in terms of its functions, and now you have got another one to add in. Okay, so all this heat, when it is too much, can be lost to the environment via these few ways, which will enable the body to cool down, also through sweating, so that you can maintain a consistent body temperature. Okay, so how is it that your body temperature is being regulated, and to ensure that it is constant, okay, is by a component in the brain which is called your hypothalamus. Okay, so when you have got increase in body temperature, let's say for example you went for a run on a very hot day and your body temperature increases, so what happens is that the hypothalamus of the brain detects that and it will activate the heat loss center. So once this is activated in the brain, the components of your skin, your blood vessels, your arterioles and your capillaries will come into play. Okay, so capillaries and arterioles, they dilate, so which means they become bigger, so therefore blood is able to move to the region. Okay, so at the same time, if your stool goes through, your shunt vessels will constrict. Okay, so let me just write that down. So we will have the shunt vessels that will constrict as well. So when there is simultaneous constriction of the shunt vessels along with the dilation of the arterioles, blood is able to stay at the skin surface for a longer period of time. Okay, which is why when people are feeling hot after a run or exercise, they appear flushed, as though they are blushing, simply because you have got more blood at the surface of the skin. Okay, so by being at the surface for a longer period of time, heat can be lost through conduction radiation. At the same time, breathing rate also increases because exhalation is a way to remove heat from the body. So your breath feels hotter after a period of exercising. Okay, so less heat production internally because there's already so much heat from from exercising. So metabolic rate will slow down. Okay, so conscious actions, these are voluntary actions, things that, for example, you fan yourself, cool the environment down, etc. Okay. Now the opposite takes place when the body temperature falls. So again, the same thing, the hypothalamus is activated. So instead of dilating, okay, your arterioles and your capillaries will constrict. So in this, the earlier part here, we learned that your shunt vessels will constrict. Okay, so the opposite will happen here. So over here, what happens is that your shunt vessels, on the other hand, will dilate. Okay, so when your shunt vessels dilate and your arterioles along with capillaries constrict, that will bring blood away from the skin surface. Okay, so when it brings the blood away from the skin surface, it helps to redirect the blood to core organs such as your heart. Digestion rate will slow down because at that point in time we don't really require digestion. That's why for some people, when they are exposed to extremely cold weather for long periods of time, frostbite happens. And frostbites normally happen to the extremities such as the toes and the hands, the fingers itself, because blood is being redirected away from the skin surface layer. Okay, so heat loss is also reduced. Okay, you have got increase in metabolic reactions to increase more internal heat production. Okay, there's also conscious effort such as moving to a region that is hotter or at least trying to get more heat. Okay, now shivering is very unique because when you shiver, there's actually very extremely rapid muscle contractions. So these rapid muscle contractions will result in more heat production because respiration is occurring at a rapid rate. Okay, so just recall that when we have got rapid muscle contraction, respiration takes place, so which means to say that there is an increase in metabolic activity. Okay, so all in all, these actions are taking place in the hopes that your internal temperature will increase. Okay, so that is what that is happening here. We have got thermoreceptors in the skin. Okay, so when the body temperature falls, thermoreceptors in the skin will inform the hypothalamus in the brain, which will then activate a series of actions hoping to get the body temperature back to normal. So likewise, when the body temperature rises, thermoreceptors in the skin detects it, will inform the hypothalamus of the brain, which will then have a series of actions that take place that will correct the mechanism to get the body temperature back to normal. Okay, now this is the last part that we are looking at for the skin. Okay, moving on, we'll be looking at excretion, starting with the anatomy of the kidneys. Thank you for watching.